Okay, today we are going to walk through one of the hardest cases. This is the simple case by Michael Jarman. This man here has caused a lot of pain for everybody that did this one. And the premise is extremely simple. You have to add, subtract and multiply some numbers. The problem is they are very large numbers that Excel cannot compute. So you need to find a way to do this without using just the addition and multiplication in Excel. So the people that did best on this case, I imagine, are those that used Python. However, you're not supposed to do that. You're supposed to do it purely in Excel, which can be done, but it's hard, as you'll see. And essentially what we're going to do is go back to high school and do the long addition algorithm and multiplication algorithm and build it in Excel in order to solve these. So question 1 is asking us to sum up the digits of these questions, and that's how we're going to provide the answer to all of the questions. So what we want to do is split this out number by number. So there's a trick for that. You can say mid here, and then we want a sequence, so we get an array of the length of that, and then we want to return one character at a time. So what you'll see is that gives us all these digits split out: 58804, 58804. These are actually formatted as text. If we want to sum them up later, we want to times them by 1. That will convert them into numbers here. Then we can operate on them by summing individual things at a time. What would be even more useful with this is to have this spit out in reverse order. And the reason for that is later on when we're going to add two numbers, if you remember back to first school, middle school, whatever, you want to add up all the units in two numbers, then the tens, then the hundreds, then the thousands, and everything in those positions going up in multiples of 10 to get your answer. So just skip into question 2 so we can see that. These two numbers, I want to add the final digit. So 3 plus 2 will give me a 5 on the ones, and then 5 plus 0 is going to give me a 5 on the tens. So I kind of want to add the digits in the numbers one by one. But I always want to start the ones, then the tens, and the thousands, so then I can carry something into the next position if the sum is over 10. So to split this in reversed order, I can amend the sequence to start at the final position. So that's going to be the length of this again. And I can move in steps of -1. So that then is going to flip this on its head. So we get 00803, 00803. And that's formatted as a number. Now we are going to have to basically do that for every number in all of these questions in order to operate on them. So let's turn it into a lambda, so I have one formula that just does it for me. So I'm going to say lambda, and this is how to make your custom formulas. Most of you would have done this already if you're watching this video. And then let's just say nums1. So, and we're going to put nums1 into our formula bar for everything. That's our lambda, so let's enter it into our name manager. New, here's our formula. And we're going to call it reverse digits. Let's say rev digits. Okay. And now I should be able to say rev digits of this number, and it's going to spit out that list. Perfect. So the first question is then going to be equals sum of rev digits of this. Okay, question 1 done. That also means we can do the first bonus. What is the sum of all the digits of the numbers in every question? So let's pull all of the numbers in the questions into a new tab. I'm actually going to remove this answers tab. We've got these. Okay, so let's, we've got all our numbers. Let's two-col them, so we have them individually. And then let's say, I don't know if this will work on an array, but reverse digits of that. No, it doesn't work on an array. I didn't think so. I'm just going to reduce the size here. There we go. So let's say equals rev digits of this. We want to sum them up and drag that down, and that should be our answer. 50103 is the sum there. So back to the top, 50103. And we can actually do the second question now as well. So this is just asking us to add all the numbers up that are divisible by 3 and all the numbers up that are divisible by 7. Now, you need to know a few maths tricks here. If not, you would probably have had to Google, you know, divisibility by 3, divisibility by 8. And what you would learn is that a number is divisible by 3 if the sum of its digits is divisible by 3. So we can't do mod 3 on the large number because it's so big, but we can do it on this number and say mod 3. And if it results in a 0, it means that that number is divisible by 3. Divisibility by 8 is another maths trick where if the last 3 digits are divisible by 8, then the whole number is divisible by 8. That's because 1000 is divisible by 8, so everything up to the final thousands digit is going to be divisible by 8, and it's only then dependent on the last 3 numbers. So we can say right of this, comma 3, that's going to give us our last 3 digits, and then we can say mod that's 8, and if that equals 0, then the number is divisible by 8. So then we can say count if this is 0, and drag that across, and this looks way too high for the answer. Okay, we have a load of zeros in our numbers where we've filtered things, so we need to get rid of zeros in here. That's why these are too high. Let's sort this. And then we only want to do our mod calculations up to this section here. And that looks correct. So our answer is 116. 116. Okay, now we're going to actually have to start adding digits together. So let's add a little model, example 2, just to show you how it works for each one fully. XLOOKUP that in B, and we want G to H. Okay, so we have 2 digits to add together. So let's say equals reverse digits of this one and reverse digits of the next one. So to do this, all we want to do is add the digits up individually. And what we'll find is that none of these are bigger than 10, which means there's nothing to carry into the next calculation. So all we then do is do the sum of digits of all of those. So let's do sum of these, and that should be our answer. So I think it's quite reasonable to get to this position with, you know, minimal knowledge, and you'd probably be doing quite well based on the results of this case. There we go. Now is where it gets tricky. We want to do carrying. So if we change this to example 3, what you'll see is that some of these digits actually have a carrying value. So in the ones we have a 9, in the tens we have 11. So it's 11 tens, which is going to be 110. So we only want 110, and we want to carry 1 into the 100 position because we've got 110. So let's set up a carry column over here. So let's say the carry. At the start we're going to have 0 because we're not carrying anything into the ones position. And what we're going to have is this plus the carry. Then we want to do that mod 10. So let's do mod that 10, and that's going to be our next digit. The amount we then carry is going to be the full amount minus the individual digit divided by 10. So we're carrying 0, and then on the next one we have an 11, so we are carrying 1 and our digit is 1. Then the next thing is going to be a 9 because we had an 8 but we carried a 1, so this is the, you know, ones, tens, hundreds, thousands, tens of thousands, and so on. Then we want to build up what our actual answer is here. So this 9 is the units position, so this is going to go on the end. So what we want to have is the 9, sorry, we want to have the blank and the next digit. So let's call this next plus carry, and let's call this next digit. So this is going to keep building and building until we get our final answer. Now this is quite complicated to build. If you've done long addition, you could probably do it. I did it a slightly different way in the real case, but essentially the same thing. And then we should be able to answer the question. So in the final position, we carry a 1. So actually we need to tack a 1 onto the next position. So if we concat this that's kind of our answer. So let's say concat this. That is the numbers added together. We then want to get them into digits as we did before and sum them up. There we go. And let's put in our question numbers for example 3. For question 3, sorry. And that should be our answers. Then we can also do question 4, which is subtraction. So the way this is set up, it will work on subtraction. So all I need to do here is say equals this minus this. Okay, now in this case with subtraction, it's pretty tricky to think about, but we'll find out that we get negative numbers, but when you mod those negative numbers, you get kind of the remainder. So we keep the remainder and we carry down a -1 into this position, which is exactly how subtraction would work. If you subtract a bigger number from a smaller number, you know, 7 minus 9, you're going to get a -2. So your digit is still going to be that mod 10, and you are going to push back, you know, you're going to reduce the next multiple of 10 by 1 digit. Then let's change this to example 4. Let's change the question numbers. And that should be all of our answers there. So next up is multiplication, so we'll get to that in a second. But we can actually do another bonus now. We can do 2 more bonuses. So the first bonus is add all 40 numbers together. Let's actually do this 4th bonus first, because it's subtraction, which is what we're on now. So subtract the smallest number in level 4 from the largest in level 5. Now, you can't just use min or max on these because they're too big. So we want the smallest number in question 4. So what you can do is sort them. And because they are viewed as text, it's still going to sort, that's actually too cool. It's still going to sort them in order of, you know, 9 and 1 count as text. So it's the numbers are going to get bigger just by virtue of 1 in text being before 9. So that's the smallest number in question 4. So we know that we want to subtract that off the largest number in level 3. So let's say equals 2 col of this, and let's say sort. And then the biggest number is going to be at the bottom of the list, which is this one. And we have our algorithm set up nicely. So the answer is going to be 245 in this case. So let's enter that, 245. And then bonus 3, I think this is harder than bonus 4, is add all 40 numbers together in level 3. So let's grab those, which we already have a list of here. So that's nice. Let's put them into our thing here. And what we would like to do is add up all of the digits. So we're basically going to do this 40 times over. So let's actually 2-row, just so we have the same setup of this. That's going to put them all into columns. And then we can say equals rev digits of this. Copy that across. And now we just want to add these up along. So let's just do the simple way. We could do by row sum, but we will just do that. And then what we can do is we can put this into our algorithm here. So copy as values. And then this should be working. So the next digits, the ones is a 7, and we are carrying 16 into the tens position. So then we get 16 plus 198 to get to 214, and we just repeat the algorithm, tacking, you know, the 1 on, and then the 10 to the 1, and so on and so on and so on. We're going to have a few carries here because it's big, so let's drag this down just to keep adding those carrying amounts in. And then we can do this, and that should be our answer, 241. So let's check that. 241. Okay, now if you got this far on the real day, you would place 8th, and you would place above the current Excel world champion. So that would be an incredible result. However, some people did get to multiplication and so on. I think they did it with Python. But like I said, you can do it in Excel. The problem is we're going to need to create our addition algorithm in a single formula, so into a lambda, so that we can, you know, do that on anything like we did at the start with the reverse digits. The reason for that is because we multiply by 3. So this might be a long explanation, but let's do it anyway. So let's delete this tab out and use it for multiplication. So we'll call that addition. We'll call this multiplication, and let's try to explain how this works. So when you were young, and for multiplication, I remember doing it like this at school. You would do a grid. So let's take 3 numbers, let's say 5, 7, 5, and I don't know, I'm just doing this at random. Let's pretend these are in reverse order. So I'm actually multiplying 575 by 6, 1. So this is the ones position. You would multiply those together, so I'd say equals that times that. And I would do that across the grid, so, which actually we can do by just saying equals this times this with an array formula. And what we'd say is we have a 5 in the ones position. In the tens position, we have 30 plus 7. In the hundreds position, we have 5 plus 42 plus 35. In the next position, you know, we have 30 plus 49, and so on and so on and so on. So what we would love to do, so this is the ones, this is the tens, this is the hundreds, this is the thousands, and this is the tens of thousands. What color can we do? There we go. So I basically want to add everything on diagonals. To do this in Excel, you kind of need a bit of a trick for it. So what the trick is if I were to make an array, 1, 2, 3, 1, 2, 3. Now if I were to just add these, so if I say equals this array plus this array, that's going to give us a grid where you will notice again, if I format, that the numbers in each color are the same, because we are just adding up, you know, one by one across. That's just how it's going to work. So what I can do is I can basically to-call this, and I can say to-call this, and then I want to group this. So you can either use group by, or you could use sumifs really. So let's do sumifs because it's easier. Let's say unique of this, and then I want to say sumifs, and I want to sum all these digits up where this array, I'm just going to lock them, is a 2. So now we're back to our addition algorithm. Those are the ones, those are the tens, those are the hundreds, those are the thousands, and those are the tens of thousands. So if I can get my addition algorithm into a lambda, I can essentially do this method and then say, you know, do long addition on this string here. So let's build it. So I'm going to delete all this out and start building our lambda. Now, the real tricky thing about this is we kind of want to do it with a scan or a reduce, which is repeating, you know, a step over and over and over again until you get to a final result. And that's fairly easy if you have one variable. So with that formula, you'd start with an accumulated value and an array, and then you would apply every element of your array to your accumulated value one by one to get a new accumulated value and start the process again until you get to the end. The problem with this is we have 2 values to accumulate. We have a carrying amount, and we have a digit to tack on to our existing string as text. So there's a really clever way that you can have 2 accumulating values in a scan or reduce. You have to do this one with reduce rather than scan. I don't know why that doesn't work. And the way you do that is you essentially make this an array. So you have 2 things in your array. So let's say equals reduce. Our initial value is hstack. Our carrying amount, 0. And our digits so far, which is nothing, just blank text. You can't put a 0 there because, like in this first example here, we'd get 70 instead of 7. So that's multiplying up by 10 our end result, which is not what we want because that would ruin multiplication later down the line. So that is our initial value. Our array is, let's just use this for now. And our function is now the tricky bit where we want to build this whole thing out. So let's say AV. That's just a standard notation, so A is our initial value, this is our array. Now what do we want to do to A and V? So let's say I'm going to extend this formula bar. So the first thing we wanted is the next digit plus carry. So let's say next plus carry is going to be, so in our original array, this 0 is our carried value from before, nothing, we're not carrying anything. So let's say index A, that's our array, and we want the first column and the first row. So that's our carried amount from before, and then we want to plus the next digit in the array, so that's V. So our next column in our table here that we built was the next digit. So the next digit was mod of the next plus carry, 10. And the next column we built was the value to carry forward, so let's call it carry. Let's say carry forward. And that is our next plus carry minus our next digit divided by 10. Okay, so now we have all three columns of our workings here. The final thing we want to do is give ourselves an output, and the output format must match the input format for a scan or reduce. So we know we're going to have an H stack. So what are the two things we need to stack? We need to first stack the carry, carry forward. So that's the first thing. So to build a number, the first thing we want is the higher units. So we want the tens, then the ones, then the whatever. So the thousands, the hundreds, the bigger number is what we just calculated. So it's going to be the next digit. And we want to concatenate that with whatever our old string was. So that is just our index of A, and we want the first row, but the second column. So this is a tricky one to get your head around, but we're taking an input as an array, and we're using the first part of the array and the second part in the array through calculations to create an ending array, which then goes back into the start of the cycle and keeps rotating through. So now that should be our answer. So hopefully if I press enter, I get down to what we had at the bottom, 22, 7, 4, whatever, because this is where we stopped. We only go over this array. 22, 9, 0. I think I actually did these digits the wrong way around originally. It should have been this and that, which didn't matter up until then. But it does now, because we're going to reuse this to multiply, 3 digits, 4, exponentiate. So we want to do it over and over. So that is our addition formula in one cell. What we want to do is concat that so that we no longer have it as an array, and that is our answer in text form. So let's turn that into a lambda. So lambda, we want a list of digits to sum over. So digit list, and this is our digit list. And that's it. There's only one input for the lambda. So let's copy that into our name manager, and we'll call it long addition, and hopefully that works. So let's say long addition of this array gives us the same answer. Great, so we have addition built. Now let's try to build multiplication. Let's do example 5. There we go, there's our two numbers. So like I showed earlier, we want to put these into a grid. So let's say equals reverse digits of the first number, and then let's say equals 2 row reverse digits of the second number. Then we want to do equals this times this. That gives us our grid. I'm just going to reduce this down to a smaller size so we can see it. So here is our grid of numbers that we want to sum up diagonally, like I showed before. Let's now do sequence of the length of the first number and sequence of the length of the second number, but we're putting this one across. Then we can do equals this plus this. And again, let's just reduce that down. Okay, so we have two grids here. And what we want to do is we want to sum the diagonals. So we have our diagonals here. So let's 2-col both of them. So equals 2-col of this. And then equals 2-col of this. And then we have our kind of list we want to do a pivot table on. Then we can do equals group by. These are our row fields. These are our value fields. And what we would like to do is sum. So this is building a pivot table basically. We don't want headers, we don't want totals, we don't need to sort, and that should be it. So let's see what that looks like. So these numbers all go up in order, which is good, up to 100. We want to drop out the first row, the first column, sorry. And then we are just left with a list of digits we want to do addition over. So let's say long addition of this, and we get this number, which is really big. Then let's reverse digits of this and sum them up. And that's 488, which matches the example. So we have something that works. We have a method that works. The only thing is, we could now do this as a data table, but when we want to multiply by 3 numbers, we would need to do this, and then do it all over again for a whole new array with different lengths, because this number is now much longer than 50 digits. And then with exponentiation, we need to do it again. So now we need to build multiplication into a lambda, and that will solve basically the entire case, because then we can just reduce over that lambda as many times as we want to iterate over it. So let's try and build this into a lambda. So what we want to get to is this output here. So we know that B56 is 2-col that, so let's change that to 2-col of that. Still got the same answer. We know that 2-col of B4 can replace this. And now we can get rid of these steps. And then what is 2-col of BB4? That is the sequence here plus the sequence here. So we're now going to start to put this in a let. So let's say let, so diagonals is sequence of the length of this number plus sequence of the length of this number. But we want it to be, this second sequence to be in rows and not columns. So that's our diagonals. So those diagonals are going to be this bit, 2-col of our diagonals. And then we want to build our numbers. So let's say multiplication array is going to be the rev digits, so splitting up the digits of the first number, multiplied by 2 row, the reverse digits of the second number. Then we can say multi-array here. And then I think that still results in the correct array that we want. Finally, what we want to do is do long addition over that whole thing. And that gives us our answer of the 2 digits multiplied. So the final thing to do is turn this into a lambda. So let's say lambda nums1, nums2, and b1 is going to be nums1. And then c1 is going to be nums2. And that should be long multiplication put into one formula. So let's try it, see if it works. Long multiplication. So let's say equals long multiplication of this number and this number. Pray it works. It does. Great. Now the rest of the case is pretty much going to be a breeze. So we can say equals long multiplication of this and this. That's going to give us a big string. We want to do our rev digits on that, split it out, and we want to sum them together. Okay, and then we want to do it 3 times, so let's just copy the formula over. That's our first 2 digits done, and we want to do long multiplication of that and that, and then that's that done. And then we want to exponentiate over it, so this is where we can use a reduce, so equals reduce initial value is this. Our array is a sequence. This is how many times we want to do it. So if we have that number already as our initial value, that's that to the power of 1. Then we want to go 2, 3, 4. So we want to do it a sequence of this minus 1 number of times. And our lambda, let's say AV, long multiplication of our initial value and this. So that should give us a big string of, you know, that exponentiated to the power of 4. So we can say rev digits of that and sum them up. And that is our answer. And finally, nearly at the end of the case, it's a long one, it's a complicated case this. This score was the highest score of the day, so I think nobody actually finished this answer. This was the best result in the world. I assume the guy used Python because this takes a long time if you don't know how to do it. I could maybe do the whole thing in half an hour now that I know how to do it. But yeah, explaining it obviously is longer than half an hour. So what is the sum of 4 tetrated to the 3? So that's repeated exponentiation. So we want 4 to the power of whatever 4 to the power of 4 is. So let's do, this is to the power of 1, 2, 3, 4. So we want equals that times 4. So boom, boom. So we basically want 4 to the power of 256. So let's do our long multiplication again. Reduce, our initial value is 4. Our array is a sequence of 255 because we already have 4 to the power of 1 in our initial value. So we've got 255 left to go. And our function is long multiplication. And we want to do lambda a comma v. Our function is long multiplication of our initial value and 4. And that gives us a real long string, so we want to then rev digits of that, rev digits that, and we want to sum them. Done, 733. So that is how to do the simple case. This is a long video, it was a really hard case. I pretty much used Dim's method, which taught me a lot and was insanely clever with that reduce of, you know, taking 2 arguments that can accumulate over a single reduce. Really clever. If he watches this bit, then I would love to know why this does not work over scan. I have no idea. It comes out in a calc error. I don't know if it's because scan can't output arrays. Even if I don't concat the whole thing, it doesn't come out. I would expect to have this whole array come out as I've written it out longhand there, but it doesn't. It only comes out in a reduce. Love to know why that is. Anyway, that's the end of the video. Thank you for watching.